At 9:14, Donald receives message 1 from Judy. He sends back a separate delivery confirmation. Judy gets it at 9:15. There is just one problem. She does not send message 1 until 9:16. That is a delivery receipt arriving before anyone places the order. Judy and Donald are 2 robot outposts inside a simulation. No physical wormhole has ever been observed, so we built one out of mathematics and put it to the test. I'm Julian. Eliza and I are reviewing the results. We will judge this shortcut the way you would judge any new road. Does it connect? Does it stay open? And does it keep events in the right order? The clock trick behind the receipt comes last. First, Judy needs a route to Donald. A tunnel through a hill beats the long road around it, not because your car is faster, because your route is shorter. A wormhole asks a bold question. Could space-time itself hide a shorter route between 2 faraway places? In 1935, Einstein and Rosen found a bridge-like shape hiding in the equations of gravity. They were studying particles, not planning a road trip. Still, it is a connection on the map. Judy aims a light signal into the bridge. Donald waits. And waits. Nothing arrives.
If the geometry connects both sides, why can't even a light signal cross?
Because a connection in an equation is not yet a journey. Think of a transit map showing 2 station symbols with no train line you can actually ride between them. The map is honest about the shape and silent about the ride. This bridge is built from black hole geometry, and inside it, every path that points toward the future also points inward. Nothing comes out beside Donald, not even light. So a black hole is not a shortcut that nature already dug for us. Test 1 fails. Judy wants a route that works in both directions, has no one-way horizon, stays gentle enough to survive, and holds open long enough to cross. That is quite a wish list. The simulation grants the wish. The redesigned throat has no horizon, and the path opens out again on Donald's side. Its narrow waist is a little like a fabric tunnel held open by hoops. That explains the shape, not what could actually hold space-time open. Judy sends another light signal. Donald receives it. Judy celebrates by mailing a small red probe about the size of a lunchbox. It comes out whole on Donald's side. After one failed bridge, the shortcut has finally done something useful.
The probe crossed, but what did the simulation have to assume was holding the throat open?
That is where the design turns into a wish list of its own. Ordinary matter and energy make gravity pull light together. At an open throat, the light has to spread apart again. In standard general relativity, that takes an unusual pattern of energy and pressure. People shorten it to negative energy. Negative energy is not antimatter, not dark matter, and not a liquid you could order in bulk. Quantum fields can dip below the vacuum's usual level in special situations, but quantum theory keeps those dips tiny and brief. Nobody has a recipe for gate-sized amounts, and one crossing is not a safety certificate. One truck making it over a bridge does not promise the bridge survives years of traffic. Some studied wormhole models collapse if you look at them sideways. Others work only under conditions nobody knows how to build. So test 2 earns a conditional pass. The route works if unknown support exists and if the throat holds. Judy and Donald are happy to keep simulating. They are not sending a person. Now we have earned the strange clocks from the beginning. There are 2 pairs. Judy and Donald each keep a wall clock, and before the test, ordinary light signals set both to one shared laboratory time. The wormhole mouths carry wristwatch-like clocks of their own. Those start together until one mouth takes a hypothetical trip at nearly the speed of light and comes home with 2 minutes less on its watch. Neither watch is broken. 2 odometers can disagree because their cars drove different roads. These watches disagree because the mouths took different paths through space-time, and here they measure time, not distance.
The mouth clocks disagree while Judy and Donald's clocks stay synchronized. What is each pair measuring?
The wall clocks label events in the shared lab. The mouth watches record how much time each mouth itself lived through. We parked the younger, travelled mouth beside Judy and the other beside Donald, 1 light-minute away. The model adds one more assumption. Equal readings on the two mouth watches stay connected through the throat like matching page numbers in two copies of a book. The watches label the connection. They do not create it. At 9:16, Judy sends message 1 into the younger mouth. Under the pairing rule, it exits beside Donald at 9:14. The crossing itself is too quick to change the displayed minute. Donald sends back a different signal, the delivery confirmation, traveling through ordinary space. 1 light-minute of distance takes 1 minute at light speed. Judy receives it at 9:15. 1 minute before she presses send. That is the impossible receipt. Message 1 took the shortcut. The confirmation took the long way. The universe's speed limit was obeyed at every step. The order of events was not.
Does every traversable wormhole become a time machine once its mouths move?
No. The loop needs 2 extra favors. The pairing must survive after one mouth falls behind, and message 1 must land far enough in the past for the confirmation to beat Judy to the send button. Plenty of traversable models refuse one favor or the other and stay causally safe. Stephen Hawking suspected nature refuses harder than that. He suggested quantum effects might grow enormous just as a time loop tries to form and destroy it. He called the idea chronology protection. It is a serious conjecture, not a proven safety system. Test 3 fails. Judy and Donald reject the route for travelers. So, could you actually travel through a wormhole? The equations allow models of one. Nature has shown us none, and nobody knows how to build one that is large, stable, and safe. Judy and Donald's impossible receipt needed 3 gifts from the simulation: a route with a future path through it, unknown support holding the throat open, and an arrival far enough in the past for the receipt to beat the order. The 2 of them are fine, by the way. They still talk every day. By ordinary light, the long way round, receipts arriving after orders, the way receipts should. And the failed machine still earns its keep. It forces gravity, quantum physics, and cause and effect into one room and makes them argue. For now, a wormhole is a brilliant map of what physics has not yet explained, not a destination we know how to reach.